First of all, good morning, good afternoon, good evening, depending where you are joining from. Welcome to my session about Apache Spark for SQL data warehouse developers. Before I start the session, first of all, a big shout out to the organizers, of course, and I would like to thank them for having me. I like to speak to the community, especially through user groups and free events. So I'm very happy I would be able to be joining today. So, who am I? My name is Olivier van Steenlandt. I am a Microsoft expert working for a consultancy firm called DataShift. DataShift is located in Belgium and the Netherlands, and we're basically a tool agnostic company, so we just look out what the best solution for our customers is. Besides DataShift, I'm a core member for Datamines as well. So for those who don't know Datamines is the Belgian data user group focusing on the Microsoft data platform. And in the past few years, I've been taking up the role as president for Datamines. Besides Datamines, I do a bit of speaking and blowing as well, always about things where I'm running into on my day-to-day job, or things where I'm running into where I'm just fiddling around with technology. And about 2 or 3 years ago, I got awarded with the Microsoft MVP Award. When I'm not doing anything technical, I like to run, cycle, and swim. I actually started running a few years ago, wasn't very great at it, so I started cycling, wasn't very great either, so I started swimming. And then this year I started with triathlon. I was like, you know what? If you can be bad at one sport at one time, why shouldn't you be bad at 3 sports at the same time? So I just started with triathlon. I actually like it. And I just registered for my very first Ironman 70.3 as well. So I'm taking up the challenge next year in August. In case you have any questions throughout the session, feel free to ask away in the chat window. There will be plenty of time at the end of the session. So feel free to ask away. If you have questions tomorrow, next week, next month, doesn't really matter. Feel free to reach out. You can find my contact details at this moment at the bottom of the slides. I will be sharing them later on as well. Just feel free to contact me. I'm more than happy to help where possible. Today, I'm going to take you on a journey that started for me with Apache Spark about 13 years ago. So don't worry, I don't have 13 years of experience with Spark, but I started with Spark in 2013, 2014, around version 0.4.7, I guess, or 4.1. It has been a long time ago, and Spark has been evolving crazily over the past few years. I actually took up Spark again at the beginning of this year, and I was very surprised to see all the capabilities that were added throughout all these years. So that's the reason I actually started with this session. So first things first, we're going to discuss what Spark is very briefly. I'm going to get you throughout the basics. And then, of course, where the session really is about is I want to show you what you can do with your SQL skills. That's where this session really is about. We're going to discuss some more advanced skills. Well, I at least think about them as more advanced skills. And then, as mentioned before, there will be more than time enough for Q&A at the end of the session. So, first things first, what is Apache Spark? And what I like to do is, well, I'm not that creative to define it for myself completely. So what I'm doing is, you know what, I'm just going to look up the definition. In this case, Apache Spark is a multi-language engine for executing data engineering, data science, and machine learning on single-node machines or clusters. The most important thing here is it is a multi-language engine, and it is for data engineering. That is my point of view. Now, why multi-language? Well, you can interact with Apache Spark in a couple of different ways. You can use Python. You can use Scala, Java, and R. Let's say if we take a look and we go back 13 years ago, you had all these options available as well. But at that point in time, Scala was the way to go. So my first steps with Apache Spark were through Scala. Why? Well, at that point in time, Scala was the most performant way to execute Spark. Nowadays, it doesn't really matter anymore. And in all fairness, I switched over to Python myself as well. But there is more. Why? Well, over the years, they have started to build upon the base set of Apache Spark, where we're going to take a look at a bit later throughout the presentation. But they added a component called Spark SQL. And Spark SQL was created for structured data processing with a specific SQL dialect. Just some information about it. It has been based on the ANSI SQL 2003 revision. It is Hive compliant by default, but not ANSI compliant by default. Although, apparently, around June, when the newest version of Spark was launched, it became ANSI compliant by default as well. Nowadays, it still isn't ANSI compliant by default in Fabric, though, just that you know. Now, let's switch back to Apache Spark as a language. Just a brief history lesson, and don't worry, I'm not going to bore you with the endless history of Apache Spark. Just some things you probably would like to know. Apache Spark originally was created by someone called Matej Zaharia at the Berkeley's AMP Lab in 2009 in the University of California. Then, 4 years later, in 2013, it has been donated to the Software Foundation of Apache. And that's how it became an open source project. And it isn't well, I really like open source projects, and that was one of the reasons I started with Spark that long ago. If we take a look at the more architectural overview of Apache Spark, then what you can see is that all started with the Spark core. And that's where I started with that many years ago. And then everything was based on resilient distributed data sets. Basically what it was, it brought out the solution to work with data in a distributed way for the very first time. It was pretty challenging though. I don't want to provide the history lesson, but at that point in time, there wasn't such things as Spark SQL and DataFrames, for example. And let that be the point where we are going to focus on today. So we're going to take a look at one component of Apache Spark, which is Spark SQL and DataFrames. And just to make sure that I set the scene clearly, what we are going to discuss today is, well, what do I really expect from you today? That you at least know some SQL syntax, mainly select from where group by, having an order by. You don't necessarily need to know the Spark syntax. And then, secondly, delete, insert, update, merge, and pivot. If you don't know merge and pivot, that's okay. If you know the concept, that's more than fine enough. So now we are on time to get through the basics. So what are we going to do? I didn't mention it earlier, but I don't really like theoretical sessions. So that's quite bores me very fast. So I like to keep things very practical. Don't worry, I'm not going to type everything throughout my keyboard throughout the session. I did record all my demos to make sure we can get the most out of it throughout the session. And as a first example, what we're going to do is, well, while you have the hello world in the software engineering space, as an example, I would like to start with Apache Spark by reading a CSV file from my Lakehouse in Microsoft Fabric. My CSV file has a header row with all the column names, and it is tab delimited. So what we're going to do is we're going to learn how to read a general CSV file into Apache Spark. So I'm opening up my notebook and I've prepared the code, and we're going to read our CSV file into a data frame. So my data frame is called df. And then we're going to use the syntax spark.read. And we're going to say, hey, it is a CSV format that we want to process. And then, well, it has a header row. So our first option that we're going to provide is say, hey, there is a header included, and it is tab delimited. And you know what? Make sure to load the file located on this specific location in my Lakehouse. That's what we're doing over here. If we execute that code cell in my Microsoft Fabric notebook, and we're displaying the data. So that's what we're doing next. And this is a very useful function, the display function in a new notebook. It is going to provide the overview of our data frame, of the data that really is included. If you take a quick look at the headers, well, what you will be seeing is, hey, all the different columns are read as string values, which is not very good. So we're going to solve that in a moment. Now, what I want to show you as well is, well, my data set has 209 columns, which might be a bit too much for this exercise as well. Before we're going to solve this issue with the data types, one thing I would like to mention is, well, as mentioned, everything is loaded as string values. If you want to have an easier way to check your schema of your data frame, what you can use is saying, hey, dataframe.print schema, which is a function, provides you the schema of your data frame. So in this case, as you can see in the example, everything has been loaded with string values. So let's solve that issue. So I'm going to create my schema up front in this case. So I'm going to define, hey, you know what, import all my different data types that are available in Spark SQL, and then define the structure type for my product schema. So structure type, and then I'm going to define every single structured field. What do I do? Well, my first field is my code. It is a string type, and I don't want it to be to be a null value. That's what I'm defining over here. That has been a tremendous job to do for all 209 columns, and I'm not going through them all. But hey, as you can see, this is something you can do when you need to read a CSV file. What we can do then is, well, use the same drill as we did before, saying, hey, I want to create a data frame in a CSV format. That's my source file with a header, again, tab delimited, and I'm going to provide the schema for this CSV file. So I'm going to provide my product schema to my load function, and from that same location. If we then take a look and we display the data again, you can see, well, the code was a string value, the URL a string value, and then we get an integer value, a timestamp, and so on. So this issue has been solved. Now, if we then print the schema again, you can see that it did define all the data types properly in this case. So everything seems to be pretty okay. So, as I mentioned before, everything is properly defined at this point in time. So this is a very good first step to read CSV files, for example. And I do agree that, since I'm trying to keep a hold on the chat window as well, I do agree that having a schema is pretty nice as documentation as well. So what did we learn? So we have been seeing a couple of things in practice. Then I'm going back to the learnings of this. If we import all our data types from the SQL library in Spark, we can define a schema up front. This can be helpful. It can be challenging though as well. Then, and that's something I actually didn't show very properly, is actually what I defined was, well, for the structured field code, that was my primary key, sort of speak. I said, hey, it shouldn't be nullable. What I didn't show you is, and if I go forward one slide, you will be able to see it though. When I asked for my print schema, I said, hey, nullable true. So that still is something, for some reason, this is still going wrong in the Spark engine. I have no clue either. Now, then what we learned as well at this point is, hey, if we want to read a CSV file, we can use spark.read.format, provide the format, CSV file in this case, a header option, a delimiter, a schema if we want to, and then we point to the location where the file is available. In this case, it is my Lakehouse. It can be on on any location you want to, basically. Cool. So, as mentioned before, the print schema functionality is something I am using quite often. So, I do see a question coming in. I'm just going to hop into it as well. So, what about loading
loading a Parquet file instead of a CSV?
Well, basically, you can load a Parquet file as well. I'm going to show it in a later demo, so then it will be solved as well. Basically, you can read any kind of file into Spark. So, I'm going to get to that in a moment. So, just as a basic example, a CSV file, later on, we're going to do a Parquet file as well. Now, as a next step, so what we actually learned already, and that's on this slide or even the slide before, is we actually learned the from statement from SQL. That's what we did over here. It has been a bit more extensive though, but hey, this is our from statement as we know in SQL. The next thing we would like to do as well, we want to learn how to select specific columns from our data frame. Why? Well, for example, in this demo, it is way too much of a stretch to use all the 209 columns. We are going to minimize them to 7 columns that we're going to use throughout the next example. So what are we going to do? We're going to create a new data frame with a specific set of columns. How can we do that? Is saying, hey, my data frame dot select, which is a select statement in T-SQL or in SQL in general, and then I'm just providing all the column names I want to have between double quotes and comma separated. That's something I can, and I'm just closing off with a bracket. If we then display this data frame, as you can see right now, I only keep that 7 columns, still with the proper data types. In the past, this has been an issue as well. I'm very happy it has been solved in the meanwhile. So this is the first step. We learned from statement and we learned how to select specific columns. So it shouldn't be too hard. It's dataframe.select and then specify every single column you would like to use. Now that we know how to select from a certain, let's call it a table, let's call it a data source, and we know how to specify the columns we want to use, we need to learn how to filter our data. As data engineers, these are typical steps that we're doing when, well, processing data, cleaning data. So that's actually basically the order I'm going to follow as well throughout the presentation. So in the upcoming examples, what I'm going to do is, first things first, I'm going to show you how you can filter on text values. I've been fiddling around with it a bit. I found some interesting cases. And then I want to show you something very specific, how you can filter on more complex structure types. For the question about loading a Parquet file, it will be pretty interesting to take a look at the second example, where I'm going to filter on complex structure types. So if we take a look to filter out a certain column value, in this case, I created a data frame. I'm going to filter my data on a certain Nutri-Score grade. In this case, I want to have all the, well, I will call it the most healthy products with a Nutri-Score grade of A. And I know there are results, but I don't get any results for some reason. And I couldn't figure it out until I was like, hey, you know what? Let's try it in a different way. Same drill, dataframe.filter, but then instead of using a capital A, using a small a lowercase a. And now I do get my results. So the learning here is, if you want to filter on specific textual values, it is case sensitive, which was a surprise to me though. What we can do as well, as you can see, is use a function called where, which basically is just an alias for the .filter function. What they like to do in Spark is provide some syntactic sugar, some aliases to do the same thing. What I can do as well, and let me pause for a moment, is go more like the SQL way of working, saying, hey, you know what? Filter out some data and I'm going to provide some kind of SQL statement. So between double quotes, I can say, hey, column name E with 1 equal sign is equal to, within single quotes, A, which is already more like SQL in comparison with the other one, of course. Now, if we take a look again, we can actually do the same with, and we're going to get there in a second, same result. And then finally, we're going to do the same with that where functionality, which just is syntactic sugar for Apache Spark. Again, with the same result. So what did we learn at this point? Well, or at least my hard learning when I was fiddling around with Apache Spark again, is that if you want to filter on textual values, a capital or lowercase really matters. So it is pretty important to keep that in mind. And then, as mentioned a couple of times already, Apache Spark, or they like to have some syntactic sugar in Spark. So what you will be able to see is like, hey, you have DataFrame.filter, DataFrame.where. They do exactly the same. You can use whatever you like. The reason why they added it, at first, they only had DataFrame.filter. But then they knew, hey, since we're using a library called Spark SQL, it might be interesting to, well, add the syntax as well that SQL developers are used to. That's the reason why they added .where and some other examples as well, where we are going to get later on. What is important as well is if we want to filter data on column values, we can do the same that we can do in SQL. So equality with a double equal sign. Of course, if we're using the more SQL-like filtering, then we only need to have one equal sign. Then a difference, greater than, smaller than, a negation. So everything, well, all these are possible in Spark SQL or working with DataFrames as well. Then, if we want to make filtering less code intensive, we can import a function called the call function. And why do I believe this is interesting? Well, as you can see, I'm filtering my data and I'm saying, hey, oh, I did something wrong. That was unexpected. Sorry about that. There we go. Back to this example. There we go. Somewhere over here. Yeah, almost. There we go. This is it. So what I did over here was saying, hey, you know what? Instead of providing the fully qualified name of dataframe name dot column name, so dataframe dot, or in this case, df product selected dot Nutri-Score grade, double equal sign a. I just said, you know what? I'm a bit lazy, so I'm importing the column function, and then I can just provide my Nutri-Score grade column name between double quotes. Of course, if you want to use the more SQL-like syntax, so getting within that filter function everything between double quotes and saying Nutri-Score grade with a single equal sign a, that is fine as well. That's something you can do as well. But this works pretty much as well. So if we now want to filter on more complex types, and I'm going to pause here because of the question that was appearing in the chat window. If you want to read a Parquet file, you can do it as well just by using spark.read.parquet and pointing to the location where your Parquet file is located. That's what you can do as well. So I already mentioned this, of course. Then I'm just displaying my data. And as you can see, I'm just making a selection of some columns. And I'm going to focus on the categories tags column. Why? Well, if we take a look over here, and I'm going to pause it for a moment to make sure I don't speak too fast for myself. As you can see, this schema is a bit more complicated. It does contain some more structured type, complex types. And as you can see, my categories tags is an array of strings. And this is pretty important because in my example, what I want to do is I want to get all the products in the category of beverages. And in this case, EN beverages. So that's the first thing I'm going to try. And when I execute this, I run into an issue. What's the issue? Well, I say, hey, you have a data type mismatch. And this surprised me since I wasn't thinking about it, of course, because I really am a SQL person. And as you can see, it says, hey, you have incompatible types. You're trying to filter an array of strings with a string. To solve this, what we can do is say, hey, there is a function in Apache Spark called array contains, which allows me to filter out on, on certain records with that certain category tags on EN beverages, which works pretty well. As you can see, I get the result. But the issue here is that, well, this, the array contains function needs specific strings to filter on. They need to have the full strings. Otherwise, it won't work. In my case, I want to be a bit lazy, and I just want to filter out just in general on beverages. To do that, I do have an alternative. What we can do is say, hey, you know what? We're going to use the exists functionality, which is a function in Spark SQL as well. And we're going to work with the lambda function. Now, let me pause here for a moment. What is a lambda function? A lambda function allows us to execute a specific function that we write for every single record or row in an array. It's going to execute on a row by row basis. That's what it's doing in the backend. So in this case, I'm just going to check every single line in that array if it contains the word beverages. Then I'm going to write my filter condition. I'm going to use that exists function, and I'm going to say, hey, use this lambda function called beverages and check if you can find any results. If we execute this, well, we get the same result. So that's what we can do as well. So if we quickly summarize what we did, we actually learned how to filter more complex types. First, with the array contains function in Spark SQL, which we need to import if we're working with DataFrames. Secondly, a more elaborate function exists where we can use a lambda function to, well, to be a bit more lazy and just search for specific strings that we really want to search for. Now, we learned how to, well, select our data, or select our columns at least. We learned how to define which file we would like to read, as we do with our from statement. Then we also, well, now learned how to filter out data with the where clause or with the filter clause in Spark SQL or with DataFrames. The next thing, what we do as data engineers quite often is cleaning our data. So as next step, we're going to go through a cleanup process. In my case, I'm just a bit obsessed with Nutri-scores. I'm sorry for that. I'm going to create a data frame which just provides me all Nutri-scores, grades, and only the unique values, so the distinct functionality which is available in SQL as well. As you can see, I do get an unknown value, a not applicable value, some null values, and I want to get rid of these. So what I can do, for example, is say, you know what, let's write a piece of code where we're going to replace our unknown value and not applicable value with null values in the first step. So I'm creating a data frame. I'm going to say, well, this data frame .na.replace, and then I'm just providing an array of strings where I want to search for. And I'm replacing them with none, which is, well, similar to null in SQL. And I want to search in the Nutri-score grade column. As a next step, and this is something I do like to do, and might be important to explain as well. What I'm doing is I'm actually creating my code in several different blocks. So if you want, you can write everything in one big line, in one piece of code. What I like to do is I just like to, well, do it a bit more in more defined steps. Let's say it in that way. So right now, in my first, I just search for my unknown and not applicable values to replace them by null values. In the next step, I'm going to clean my null values with a default value. So I'm creating a new data frame with that functionality to use the fill NA function, which is going to get all null values replaced with not provided. Again, for that Nutri-score grade column. That is what we're doing over here. If we then take a look at the result, the only thing I did was, hey, you know what, my data frame.select Nutri-score grade column, and show me the distinct values again. There we go. I have my A, B, C, D, E, and not provided. So we cleaned our data. Well, I know not provided might not be the right choosing of words though, but you get the point. So what did we learn? If we want to clean data, what we can do is say, hey, dataframe.na.replace, and then we can replace a list or array of values or string values, whatever you would like to, and replace it with something else. In my case, first with none, which was the null value, and then you can replace null values with the function .fillNA to replace it with a specified value of your choice. Now, besides filtering data, selecting data, cleaning data, what we need to do as well as data engineers very often is grouping and ordering data. So that's the next thing we're going to do. Again, based on my products, what I want to do is I'm just going to use my previous data frame. I'm going to say group by, which is our group by statement in SQL, group by my Nutri-Score grade column, and count the different results. What this is doing is it's going to create the aggregation on my Nutri-Score grade column, and it's going to count all the occurrences, all the matches. Then, if I would just execute this part of the code, it will be generating, well, a new data frame with 2 columns, with my Nutri-Score grade column, and with the column with the name count. It will provide the name count to the column. If I would be using the sum functionality or something else, it will always use that specific function name as the column name. What I like to do as well, replace that column name, of course, which is similar to using select table name as, or select column name as an alias. That's what you can do in Spark SQL as well, or with DataFrames, with columns renamed functionality. So I'm going to replace the count column name with matches found. And then I want to order my data as well. So in this case, what I'm doing, I'm using the order by function of my data frame, and I want to order by the matches found. By default, as you will be seeing over here, there we go, it will be showing everything in an ascending order. That's the default. Now, and this might be a bit strange, we're going to take a look at how we would be able to be sorting on a descending order, which was a bit funny from my opinion. So if we take a look at that solution, we're just going to use the same drill. We're going to group by that particular column. We're executing the count with columns renamed again. Then again, as mentioned before, some syntactic sugar. So there is a sort functionality as well. And then to sort in a descending order, you need to specify ascending equals to false for some reason. I thought this at least was fun. I would always use descending or ascending. In this case, with data frames, you need to use ascending false. So if we then take a look at the result, so if we take a look at the output, you can see, well, apparently my not provided grade has the most matches found. So if we quickly summarize again, and I know I'm taking quite a pace throughout this, but I want to make sure you feel confident if you need to switch over from T-SQL to Spark SQL. What did we learn? Well, there is, we just have the group by functionality, as we know in SQL. If we want to, and that's what I'm already mentioning at the bottom of the slide, there also is, well, actually, group by was syntactic sugar for the sort functionality. No, not group by, order by, sorry. So we have group by, then we can rename a column, and then order by something. And order by basically is an alias or some syntactic sugar for the sort functionality. And this is something what got me off guard earlier when I just started to learn Spark. Then I really was unsure about, hey, do I need to use sort or order by or all the other things I already mentioned. Basically, they really do the same. So you can choose whatever you would like to. In my case, I know for me, I keep using the magic word from SQL as well. So I'm still using the order by, group by as well, of course, then where. These are the kind of the SQL, the Spark functions I'm using as well. Now, and let me take a break over here. What did we already learn? Select, from, where, group by, order by. Well, we didn't learn having though, but hey, we're quite far already. So it is time to do some more complex things. We're going to learn how to join data, since that is something that we will be required to do eventually as well. And if we take a look, and again, I know, again, with my Nutri-scores, I'm going to create a new data frame with only 2 columns, my code and my Nutri-score scores. Why? Well, in my original data frame, I only have the code and the Nutri-score grade. And this really is the numeric value for that grade. It's my product code and the score. And just want to join both data sets or data frames in this case with each other. So we're just going over the data here. Again, this is my original data frame with the code, and then in the end, the Nutri-score grade, where we want to put the score next to. So if we take a look how to tackle this, first things first, let's quickly take a look at the schema again. As you can see, my 2 data frames. I know I'm doing a terrible job with showing you what I'm trying to say. I do need to fix that though. We're going to focus on the code column, the grade column, and the score column in both data frames. So how do we execute the joining process? In this case, what I'm doing, I'm going to pause for a minute as well. As soon as I selected this one, oh, there we go, a bit too early. A bit too eager. There we go. Over here, what I'm doing is saying, hey, I'm not creating a new data frame called DFC, but I'm saying, you know what, that original data frame .alias DFC. It's just a short notation for a data frame. It's really creating an alias. You can envision it like the S statement in T-SQL. If you say, hey, select star from table, and let's say table name products S P. That is what this is doing, but then in with data frames as Spark SQL. And that's something I'm doing for my second data frame as well. So df, and in this case then, and then I'm going to use the join function in Spark SQL or with data frames at least. So I'm creating a new data frame called res for my result. Join provides the other side of the join functionality. And then I'm just saying, hey, join both data frames on these particular columns. And then in the end, what I'm doing is I'm just saying, hey, select from my results, select these columns, and I can easily use that alias that I defined before. So that is what I'm doing over here. As you can see, quite an extensive list of columns. But I'm at least taking that Nutri-score score column from my second data frame. If we then take a look at the result, you can see the final result for this joining example. We get all the data we want to, the product code, the Nutri-score score, and then the grade as well in one data frame. So that's it. So what did we learn? Is joining right now. Most important takeaways over here are, well, I would advise you to use the alias functionality, which is really useful since if you're chaining everything, if you're creating multiple data frames to get to your end result, creating short notation versions of your data frames can be very useful, especially when you're starting to join different data frames along the way. Now that we know at this point in time, we create our very first result and we actually want to save this result to our Lakehouse. And there are a couple of different possibilities. What we can do, for example, is saying, hey, you know what, result.write result.format delta. So I'm going to write it to my delta to my Lakehouse in delta format. My mode is override, and I'm going to save it into my files section of my Lakehouse. That's what I'm doing over here. If we then take a look, this is my Lakehouse in Microsoft Fabric. It is my default Lakehouse. That is important to know. You can only write to your default Lakehouse. If we take a look at it throughout the OneLake Data Explorer, I'm going to Files, Silver, open Food Facts. There is my products result. I get 2 Parquet files just because I executed it earlier as well. And then I get my data log as well, my delta file. This is one way. There is another way as well, is to save your result as a table in your Lakehouse. I'm going to get to the question later on, don't worry. So result.write.format delta mode override save as table. So right now I'm going to save my result as a table in my Lakehouse. If I refresh my tables, you can see right now I get my products table. Again, what I do need to mention here is it is in my default Lakehouse. You can't write to a different Lakehouse in one session. Well, at least not in this way. So if we take a look again in my Lakehouse, instead of going to the file section, I'm going to the table section. And there I have my products table available again, a Parquet file and the delta file. This is the second way how you can save data. There is a third way, which is saving your data as an external table. So yeah, I do know I'm going to fill around with a couple of things over here, but don't worry. Just remind me, I do need to remind you of something that is in preview. But what we can do is saying, hey, result.write.format delta. And this is interesting to know as well. Where I'm pointing to right now is how you can structure your code in a code cell in a Fabric notebook. So if you don't want to have the extensive full lines of code, you can easily chunk them up with a backslash. This allows you to get a certain piece of code to the next line. Just that you know. Then my mode override, again, same as I did before. And then I'm specifying an option called path, where I'm going to say, hey, I want you to save this file somewhere else other than the default for a table. So I have my products external table, and don't worry, I'm going to show you as well. Since I was saying save as table, by default, it would be showing up in the table section. Right now, it is going to show up in the files section of my Lakehouse as products external. So that's what you can see over here. So if we quickly recap, we just learned how to save data in a couple of different ways. DataFrame.write.format delta is not optional. You need to provide it in delta format, otherwise you won't be able to save it in your Lakehouse, well, as a table at least. There are a couple of modes available. In all fairness, I've only been using append and override. Then you can save as a table, and if you want to save it as an external table, you can use the option path and provide the path where you want to save that delta file or that table. Now, a couple of gotchas or good to knows. At this point in time, and this is pretty cool functionality though, is Lakehouse schema or schema-enabled Lakehouses, whatever they call it, at this point in time, is in public preview. And I checked this yesterday, so it still is in public preview. The downside is that it is not supporting external tables as we speak. Will this be happening in the future? Maybe. I cannot confirm or deny. I have no clue. Now, what if you want to use multiple Lakehouses as a source? You can. You can use multiple Lakehouses, so you can combine data from multiple Lakehouses to calculate the result. But you can only write to the Lakehouse where you want to save your data. Or, well, you can only write or save your data to the Lakehouse, which is set as default Lakehouse. That is pretty important. If you want to change your default Lakehouse, it requires your Spark session to restart. Just keep that in mind. Cool. I have been talking already for quite a while, and we're going to get to the next section at this point in time, is leveraging your SQL skills. Now, we are 45 minutes in, and I need to be very honest with you. I have been some kind of tricking you for the past 45 minutes. I've shown you how to work with DataFrames in Spark, not with Spark SQL in general. So, what do I mean? You can write full SQL statements in Spark. So, select from where, group by, having, order by is all available in Spark SQL as well. So, why didn't I start my session with this slide? Well, then I would be done in 15 minutes. Unfortunately, although, why I started off with DataFrames is because from my belief, from my perspective, it can be very beneficial to work with DataFrames as well as a data engineer. The reason why is it allows you to combine your SQL knowledge with programming knowledge as well. So you can start to combine, writing Python, for example, with SQL statements, and you can start to generate your code as well. That's the reason I wanted to show you how to work with DataFrames first. But SQL is available, although there are a couple of minor differences. No worries, nothing too crazy. For example, in T-SQL, if we want to limit to 5 rows, we say, hey, select top 5, for example. In Spark SQL, well, it is the SQL 2003 ANSI revision. Then you need to use the limit functionality instead at the end of your SQL query. Same with is null, which will be translated to coalesce in Spark SQL, and then convert and cast in Spark SQL. Just that you know. These are the things I need to learn again when switching over from T-SQL to Spark SQL. And there are some minor differences as well. For example, there are quite some date functions as well, which are available in SQL. I did include the link, so I can provide this later on as well if it might be useful. And for example, if you want to get the date in T-SQL, you would be converting the date from a getDate function. In Spark SQL, you can just use current_date. Same if you want to get the timestamp, getDate in T-SQL, current_timestamp in Spark SQL. And then if you want to start to add or subtract dates, you can use dateAdd as an alternative in Spark SQL with an underscore then. Now, if we want to work with SQL completely, with Spark SQL, with full-blown SQL, there are a couple of things we can do. So as a first example, let's create a temporary table, which we know from T-SQL, which is called a temporary view in Spark. What I'm doing is I'm just loading up my data frame again, and then I'm saying, you know what, dataframe.create or replace temp view, and I'm providing a name. This is how you can create a, as always, date functions, yes. This is the way how you can create something which is similar as a concept of a temporary table in T-SQL. So that's what I'm doing over here. In the next example, actually already renamed. So in this case, what we're going to do, and this can be done as well in full-blown SQL, which is the alternative basically. I'm saying, hey, you know what? Create or replace temporary view called results as, and then provide the SQL statement. This is something you can do as well. In this case, what I'm doing is saying, hey, select from my products table, group on my Nutri-Score grade, and so on, and only show me the Nutri-Score grades which have more than 200,000 matches. That's what I'm doing over here. This is one way to do full-blown SQL in Spark. There is another way as well, which I'm showing right over here. I can just say, hey, you know what? in PySpark, create a data frame with spark.sql and then provide the full SQL string between double quotes. This is something you can do as well. So that is an alternative as well. So what did I just show is, well, we can use dataframe.create or replace temp view. If we have created data frames up front, I want to register to use in Spark SQL completely. If we're working already with Spark SQL, we can say, hey, create or replace temporary view based on a SQL query. Or if we want to combine both again, we can just say spark.sql and provide the full SQL string between double quotes over there to use it again with data frames. So you can easily switch over from full-blown SQL to data frames, back to SQL, and so on, which is pretty powerful in my opinion, at least. Now, the more specific things I would like to touch, and I know we are running out of time, and it might be that I'm going slightly over though. We're going to, one thing that isn't available in Spark SQL is you have no way to identify or to create an identity column, for example. It doesn't exist, but there is a workaround, and this is something I've just been fiddling around with. So I'm creating a temporary view for my Nutri-Score grades, and I'm selecting all my unique grades. So it's going from A, B, C, D, E, and not provided, and I'm creating a dimension table in this case in SQL. And then I'm saying, hey, you know what? If we take a look, there's no data in that dimension table at this point in time. So what I did was I just wrote a piece of SQL code, which I'm pretty familiar with. I said, you know what? Create a CTE where I'm going to define my maximum value in my dimension table. If I don't get any matches, well, start off with a 0 and add the row number of that certain record. That's what I'm doing over here. And only insert the ones that do not exist yet. Then, if I execute this query, you can see right now I get my first two results in my dimension table with an ID column 1 and 2. And then if I remove my filtering and I execute this piece of code, which is basically the same but without some filtering conditions, I get all my different Nutri-Scores in my dimension table. So there is a workaround. Cool. Now, since we really are running out of time, there are a couple of advanced skills which I want to tackle very briefly. Just some things I really believed were pretty cool to mention as well. In the past, when I was creating, when I was just working in SQL, there were certain things I would rather solve by programming a piece of code next to SQL, but that would have been a challenge at that point. But I can create my own functions in Spark SQL as well by using my Python knowledge. In this case, and I know Sue laughed about this one pretty much the last time she saw this presentation. So I was writing this on a Sunday morning, well, apparently afternoon already, and I was running into a product called chicken. And for some reason that day, it annoyed me that the product name of chicken didn't start with a capital C. So I was like, you know what? I'm a problem solver. I want to solve this issue. So it starts with the lowercase c. Let's change that. So what I can do is say, hey, you know what? I do know some Python. So I'm going to create a user-defined function called convert case. I'm going to import that functionality. I'm going to import the string type. And then I'm creating my function. I'm going to get to the question later on, no worries. And then what I'm doing over here is I'm registering the function I created in Python to Spark SQL. So my convert case UDF function, which I wrote in Python, can be used in Spark SQL as well. So if we take a look, and this is something which I believe is pretty useful, If you want to figure out which user-defined functions are available in your Lakehouse or in Spark SQL, you can use this piece of code, show user functions in Lakehouse. And as you can see, I have a couple, and one of those is my convert case UDF. And now what I can do is say, hey, you know what? I'm using a Spark SQL code block. And I'm saying, hey, select, use my function, execute it on to the product name for that particular code. And it returns me the chicken with the capital C. So my Sunday afternoon was splendid. I know this is a silly example, but I really want to show you this one. I really believe this is pretty cool functionality. If you have certain complex things you need to do, it might be more useful to use a Python function if you're used to use or program in Python and just add it to your Spark SQL functionality. This is pretty cool for my opinion. Now, one more thing I would like to show you is pivoting data. So I want to create a fact table in this case, and I want to get all the nutrients into my fact table. They're always per 100 grams for my products. And I did some, well, I didn't do very pretty things, but it will work in the end. So for every single article or product, I get some figures here and there, but not everywhere, of course. And I'm creating a dimension table called the nutrient, which is just a hard-coded dimension table in this case. But I'm going to focus on the pivoting part. So what did I do? I created a temporary view called fNutrient with a piece of code where I'm using the unpivot functionality. If I wanted to do this 13 years ago, it would have been a very big challenge though. There was no such thing. So unpivot, go over all the nutrient information and just unpivot it to get it onto a row level. And if we then just execute the select statement, what you will be able to see is I pretty much get the result I want to. So I got my product code, I got my nutrient ID, and I got my nutrient value. Pivots, yes. Which is, yeah. What I actually want to show you with this example is what business likes to do quite often is that, or that at least happens to me quite often, is that they're providing me a CSV file or an Excel file with different years in the columns with all different values, really as a pivot table. So I want to store it in a decent way, and that's the reason I really want to show you how to use the unpivot functionality as well. So this is something really practical which I'm using quite often as well. Now, one more thing. Now that we have this result, we want to merge this one into our real fact table, into our Lakehouse. So to do that, we have the merging functionality available as well. So I'm creating my fact nutrient, which is available in my Lakehouse by now. And if we then take a look, well, I can easily write a merge statement just as I know in SQL, in T-SQL. So I can tell you, when I start with Spark and Spark SQL, the moment Spark SQL came out, most of this functionality wasn't available. So there were certain functions available, but it wasn't this extensive. In this case, I'm just showing you that I can easily just, if it's not matching, I can insert it. I can add an update as well if I want to. I didn't do it over here. But this is cool though. If you execute the merge, it is going to provide you with, hey, these are the number of rows affected. I've updated that many rows, deleted that many rows, and inserted that many rows. This is pretty cool. And then as a result, if I just select some rows from that certain fact table, you can see my result is properly saved as well in that fact table and merged. So we are getting to the end, and I know I'm going out of time in 10 seconds, but I'm going to be very quick. Good to know. Well, in all fairness, at this point in time, there are a lot of built-in functions available. Finally, you have array functions, date functions, JSON functions, window functions, almost everything, or well, almost everything what you can do in T-SQL is available in Spark SQL as well, which is amazing. When I started off with Spark SQL, you had some date functions, but not all. So I've been writing date functions back then. So 10 to 13 years ago, I was writing particular date functions myself in Scala to use them into Spark SQL later on. And right now, they're all just available out of the box, which is pretty cool. If you want to get the full overview of functions, of scalar functions, I included the link again at the bottom of the slide. And then, before saying goodbye, I hope I was able to convince you throughout the session that you don't need to be afraid to switch over to Spark SQL or DataFrames in Spark. I hope, and I really hope, I was able to show you that your SQL skills are powerful and valuable. And I know there are a lot of people who are always trying to say SQL is dead. Well, it isn't. It is very much alive. So SQL is not going anywhere. That being said, my name is Olivier van Steenlandt. Thank you so much for joining in today. Sorry, I went overtime for, well, almost 2 minutes. I hope you have a very pleasant remainder of the day. Thank you.
That was absolutely brilliant. I think Ronnie summed it up when he said he's got a few years of DBA from a previous job, but total newbie when it came to Apache Spark. And he learned a lot, and it was really well structured. That was my overriding experience from the session that you did at SQL Bits. I loved the way after each chunk of learning you summarized it before you went into the next, and it was so well structured with the flow of building from the basics and then filtering through and scaffolding on top. I think, it was completely excellent session, and it really was easy to understand. You can tell you've put a lot of work into explaining that. So yeah, it was very motivational, and it was a really excellent session. So I'm so thrilled that you were able to do this again for us.
It was my pleasure.
And I enjoyed it the second time round even more than the first, because you can really, the first time you sort of take it in, but when you go to a conference, you're just attending so much, you don't take it all in, and you don't. So yeah, this was brilliant. Ronnie's going to data mines.
Then I will see you next week. Please come and say hi.
Yeah,
we can have a chat. I will be quite busy, but I do make time though.
Yeah. Come and say hi, tag yourselves and put yourselves on LinkedIn so I can see, because I'm in envy of you all being there. But that was absolutely brilliant. There was lots and lots of thanks and appreciation from those that joined, and anyone that is interested in this. The video will be out and it will be on YouTube, so we'll be able to come back and have a look. And just simple things like what Col does, the fact that you don't then have to reference all the tables, and just the little steps like that make so much time. And Ruben said he's just come from using Snowflake, and in Snowflake it automatically creates a data frame for every cell, so you don't have to create a temp view, it just references the previous cell. So let's make it so much easier, because that's what you need, really, isn't it? Each cell block does a specific thing, so that you can really structure.
If you want to, you can put loads more in cell blocks. What I like to do is keep them pretty small, just because if you're using notebooks, you can easily add markdown cells as well, just to create some documentation in between steps.
Yeah, definitely. I mean, markdown is so incredibly helpful within the different cells. Oh, thank you so much. That was absolutely brilliant. I
My
really
pleasure.
enjoyed that, and I like the fact that you're into your NutraSuite, and that on the Sunday morning after being out, you'd spent the time. So I sit there sometimes when you've been training or you've been out or something, and that's when you can just sit and play. But it's always worth having something you're interested in
Yep.
that drives you forward to try and explore the tech. So we have no session next week. I'm away at a conference. I listened to it at a conference in the States, and then Chicago Marathon a week on Sunday. Yay!
Good luck.
Yeah, no, exciting. And for those that haven't heard, I've got into Boston, so I'm going to be running Boston Marathon in April next year with a time qualifying place. So I'm super excited about that. So we'll be back in 2 weeks' time. Yeah, lots of stretching before and after Takimi. If you really want to be bored, I can tell you the different types of stretching you need to do before and after. But you don't want to go there. Anyway, everyone, have a lovely evening. Thank you so much. That was brilliant. I really enjoyed that. Let me stop recording. Recording stopped.